Hello everyone. So last class we had a look at what is 1D, 2D and 3D data in Python. And today we are going to do some practice creating 1D data using some simple math equations that you learn in elementary school levels and visualizing them using the Matplotlib. Let's get started. First equation, y equals x plus b. So in this equations, this equation basically applies to any two number of addition. In this particular case, the x is a variable that it's changing, and the b is a constant. So y is the result of a plus b, and that makes y dependent on the value of x. So y is a 1D data dependent on the x. Just one extra comment: if we make the b not a constant, if we make the b also changing, then the y will be dependent on the x and b, which makes y a 2D data. Okay, so to keep things simple, we're going to keep the b as a constant, meaning it's not changing, it's a fixed number, and we make the y dependent on the x. You might be amazed at how many principles in nature actually can be represented in this very simple formula. And we will talk more about that when we get into collecting some sensor data and plot them in Matplotlib in the later lectures. So now, to be more, so now let's substitute the x and b to be more specific and to make sense what it does. Okay, so see, the 3 represent the b, and the first number represent the x. So if we put this formula, if we substitute actual number into this formula, then they might look something like this. What is 2 plus 3? What is 5 plus 3? What is 12 plus 3? 1 plus 3? 6 plus 3. So the 3 is a fixed number, and we allow the first number to vary. So in the very beginning, when we do math, we actually use actual numbers. But now, since we use variables to represent them, and we can write a very simple code in Python to try every single possible numbers for the x and visualize them, what it looks like. What is the relationship between y and the x? So let's do that. First, we need to use Numpy to create a sequence of numbers. So before using Numpy, we have to import them. And this is a standard way of importing NumPys. Import NumPy as NP. Because NumPy has many useful functions, we usually rename them as a very short NP. Okay? Second, now we use the NumPy arrange functions to create a sequence of number for the x. And these numbers start from -10 to the maximum of 10, and we specify a incremental stepping of 1. So let's run this cell, and if you want to see what's in x, you can uncomment this line and run it again. So now we see the x is -10, -9, blah blah blah, all the way to 9. Okay, and now let's define a number for the b. Excuse me. Let's define a number for the b and calculate what is y. Okay, so we're going to make b 1, and then the y is simply x plus b. Okay, and after the calculation, again you can uncomment this line and see what's in y. So we have minus 9, minus 8, and all the way to 10. Okay? So there you can see that if I print out both x and y, we see that we have a minus 10 for x, minus 10 plus 1 is minus 9. Okay? When x is minus 9, minus 9 plus 1 is minus 8, and etc. So we are calculating y for every value in x. And that now we can use Matplotlib to visualize this equation. First, before using Matplotlib, we have to import Matplotlib. And if you're using the mu editor, you don't need this line, okay? The magic function of Matplotlib of inline, you don't need to use this line. So just the import of the first line, okay? So let's import Matplotlib as PLT. Again, the PLT is a conventional name that everyone uses when we import the pie plot from Matplotlib. Next, what we'll do is first we create a figure. The figure just means that this canvas where we draw the plot on it. So this is a blank canvas. It's called the figure. And then because we have already calculated the y for each x, so we're going to plot them using the plot function. And we can specify what kind of lines do we want to use for plotting them. So now I choose to use a star for each data point of x and y, and I want to connect the star using a line. So this is how the plot looks like. Each data point has got a little star on it, and then in between them I connect them in using a line. Okay? After plotting them, it's a good habit to always give it a title. Okay? So the title is what is y equals to x plus b. Yeah, I changed that letter halfway when I write the notebook. And then we also need to label what is x and what is y. Okay, in this case, x-axis is just x, y-axis is just y. But in some case, when we deal with actual real-world data, the x-axis might be time, might be country, might be length, and the y-axis might be some other values, the actual measurement, whatever the sensor data or the statistic data we get. Okay, so we always need to label the x. What is x and what is y? Okay, and the last command over here is just showing the grid line. The grid line helps us to look up the numbers easier. Okay, so here is a plot. Let me get the screen bigger. So this is the resulting plot. Very simple. And now we might be wondering, since the b is a fixed number, then I'm wondering how, if it changes, what does the plot look like? So I can actually get the program to try different values of b very easily using a for loop. Let's see what it looks like. So in order to try different values of b, now we can store all the values that we want to try into a list. So here I create a list of all of the possible values that I want to try for b, okay, and I put it into the variable of b. And then, same thing as before, I create a figure, a blank figure first, and then I'm going to use a for loop to loop through each number of b and plot a line on the plot, on the figure. Okay, so this is what the for loop look like. For bb in b, so that's for each value in b, okay, and for every value we take from the b, we put it in a variable called bb. So that's for bb in b. and we're going to calculate y for that value of b. Okay. After we calculate, we plot it on the same figure. So notice that the plot.figure is outside of the loop. Okay, when we write code like this, all the lines will be plotted on the same figure. Instead, if you put this plot.figure inside the loop, the program is going to create multiple figures. And that's not what I want. I want all the lines to be on the same figure. So therefore, the plot.figure is outside of the loop. So then I plot all the lines on the same figure and I give it a title. Actually, this title can be also outside of the loop because we just need to do it once. So after we plot all the lines, we give the title, write the labels, and enable the grid lines. And here, the legend. The legend is a little chart that we add to the plot showing, you notice that when we plot multiple lines on a single plot, the Matplotlib library is smart enough to assign different colors for the plots, right? And the legend is a table telling you which color is for what parameter. Okay, let me rerun it. So since right now we have tried different values of b, and I ask Matplotlib to associate the colors with the values in b, so Matplotlib is just going to look up which color did I use for the first line. It's blue. So blue corresponds to the first value of b. And then the orange corresponds to the second value of b. And the green corresponds to the third value of b, and so on. So this is what the legend is for. It's a lookup table showing you what color of line is corresponds to which value you use for your b parameters. Okay? And here we see the final plot. So now we can observe when we change the b value, which is supposed to be a constant, and what does the line looks different. We see that blue has the lowest b value, and this brownish color has the highest number for the b value. And it seems that when the b gets larger, the line moves higher, but their angle stays the same, right? So this tells me that this b value is controlling the horizontal position of this line. Actually, the b value is the intersection of this line with the y-axis. All right. So later in school, when you need to graph this function by yourself, like on using pen and paper, you'll be taught that if you see this b value, okay, you need to pinpoint this number on the y-axis. So the b value is the intersection of the line with the y-axis. Okay. So now we have visualized this equation, and we have also analyzed what does the b do to the equation, to the pattern of the equation. So now let's make things a little bit slightly more complicated, and let's visualize one more factor. Okay. Now, for the equation of y equals to x plus b, it can also be rewritten into y equals to 1 times x, which is still x, plus b, right? Okay, so now I've introduced another factor, is a number that we multiply the x with. So what if we change the 1 into 2, maybe 3, maybe 4, maybe 5? What is that going to do to our equation and to our lines? Okay, if we don't know and we cannot picture this line, this pattern in our head, we can again write a very simple program to demonstrate them, to visualize them. So now, since we have already learned how to use a for loop to explore possible multiple values of these factors, then we can do this right away and use a for loop to explore what does the A does to our line patterns. Okay, so now we'll fix the B to 1, and then we'll put some possible values for the A to explore its effect. So here I put 1 to 7. And then again, we create an empty figure, and then we calculate for each value in this A list, we calculate what is the Y value, and then we plot the lines on the same figure. And then we add, okay, let me update this title. We add the title, and we add the label for the x-axis, the label for the y-axis, and we add the grid line. And here I added one more command to limit how much we see on the y-axis. Okay, and later I'll show you why I do that. So right now I want to keep the plot same as our real world perspective, so they will look pretty much squarish, which meaning the one on the x and the one on the y will be the same length. Okay, and then in the end I add the legend for all of the values for the A, and I run, and this is what we see. Okay, so now let's look at the plot. When our A value is a 1, this line is pretty much diagonal 45 degrees from the horizontal, right? And if we increase the A value into 2, it becomes steeper. And if we keep increasing this A value, it becomes steeper and steeper and steeper. So now here we can see that this A value controls how steep our line is. Alright? And now look at the B. So all of the line cross one single point on the y-axis where the x is 0, that's the y-axis. Okay? And it means this B value still controls where the line intersects with the y-axis, but the A controls how steep the line is. So we can see from these plots how all of these constant change the way that the line is positioned. Alright? So this is the y equals to A multiplied by x plus b. And if the b value is 0, it just means that all of the line will be shifted down and all of them will be passing through the origin where x is 0 and y is 0. Okay? So now let me show you what happens if I don't put this y limit. So right now I limit the y-axis from -10 to 10. What if I don't put this line over here? If I don't put this line, we see the Matplotlib is going to plot all of the values. It's going to fit all of our data points into one graph, and visually the slope of the line becomes shallower. But you can also see the x-axis goes from -10 to 10, but the y-axis can go from -70 to 70. So that changes our visual perspective of the line. and that's something to keep pay attention to, is that sometimes the plot shows you a aspect ratio different than our real world. Our real world's perspection is more like this way, okay? So 1 unit on the x equals to 1 unit on the y. That's our actual real world perspection. While the Matplotlib kind of shrink for 1 unit of x, it shrinks it down so that it can fit all of the plots together, fit all of the data together. That's changing our view about these steepness of the line. So that's why I use a limit. I put a limit on the y-axis to limit them from -10 to 10, so that 1 on the x is equal to, visually same as 1 on the y. Okay, that's why I put this line here. Alright, so now we have went through 2 examples about how to visualize math equations using the Numpy and Matplotlib. The sequence is the same. Basically, first we need to import the Numpy. Okay, so I'm going to transform this last example into a complete program. So first we need to import Numpy as NP, and then we need to import the Matplotlib.pyplot as PLT, so that is conventional names for these 2 libraries. And then we're going to create a variable x, so this is the variable that y dependent on, using the np.arrange. And then you can specify the lower limit -10, upper limit is 10, and the step size of 1. So you see the documentation popping up in the notebook. And then, depending on what your formula is, you will have some constant, and they are also called parameters. Okay, so you need to put in these parameters, and if you have one parameter that you want to explore multiple values of this parameter, then you can put it as a list. Okay, and then we're going to start creating the figure. First, create an empty figure, and then use a for loop to loop through all of the parameters. And using this formula we want to explore to calculate the y value, okay, and plot the line on the figure. And then in the end, add all the title, labels, enable the grid, limit your axis range if you need it, if you need to, and then in the end, don't forget to add a legend because we are exploring this parameter. So therefore, we need to add a legend so we can look up which color line is for which value of A. Okay, so this is a complete program of exploring a math formula for y equals to ax plus b. Okay, so the lecture ends here, and now it's your time to practice. I would like you to try for yourself, plot the following equations and answer these questions. So I give you 3 equations, okay, and then you're going to take this last example and then plot them yourself. And I want you to tell me, are these 3 equations the same? Are they the same? If they are not, then which one is the same as the other? The same means, is this equation equals to this equation? Okay, so that means, that's what I mean by the same. Second, what about these 2? So notice here I put a minus sign before the A parameters. So what is that gonna do to our lines? How does line changes when we have a minus sign on the A parameter? Okay, so this is the second question. And What if you learn some new equations in school and you just can't, you have trouble visualizing it? Any arbitrary equations. What are you going to do? Well, with the code right here, you can modify it so that it will show you a visualization about your new formula. Okay, so how do you modify the code to plot a new equation that you have never seen before, which is this one? Try to plot this equation by modifying the example code above. Okay, so this is the homework for this lecture. Okay, I'll see you next week. Bye bye.